So, hello everybody. I think the chair said that they are not going to attend, or they are not available to attend, basically. So, perhaps I have some stuff that I can share, and probably we can wait a couple of minutes to get started. And probably, if possible, can one of you take notes? Sure, thanks. I will have a look afterwards. Thank you, Sal. So probably I think I will share the slides and in a minute we can get started. Okay, so I have put together like 5 slides to just start the discussion on this. So there was a lot of discussion on RATS working group around these topics, and I'm kind of um, like going to start the discussion to see here if people have some perspectives or insights to share. Um, the very first thing that I want to talk about is a misconception in the two terminology, which is authentication and attestation. And in the RATS working group, there was a lot of discussion. I was trying to draw a fine line between what exactly these two terms are. Um, so in my world, at least, authentication means it has somebody has some long-term credentials by which it could be identified. And attestation, on the other hand, has something to do with the measurements. That's the kind of the world I am in. So, uh, of course, feel free to interrupt in between. And it's supposed to be more like discussion of the whole thing. And with this view, how I see this is a hierarchy of keys that we typically have, like the key for this world, that is the attestation world, is the attestation key. This is provided by the manufacturer. This has nothing to do with any human at all. This is done by the manufacturer and also verified by somehow going back to that chain to the root key of Intel or ARM, AMD, whatever that entity is. And from the authentication part, we can have like any protocol for authentication. One example that I have from of course from confidential computing, we all solutions to my knowledge use the TLS protocol, and there we have this something called TIC, TLS identity key. And in the standard TLS, that's basically a long-term key. As I defined authentication, first of all, it's always supposed to be long-term key that's signed by the certification authority. And then we follow back that chain of trust back to that root certificate to see whether it was a genuine entity, what it claimed to be or not. But what we have typically in confidential computing, or at least to all solutions to my knowledge, actually use the ephemeral key rather than this long-term key, meaning that that's ephemerally generated key within the TEE, and that replaces rather than augment attestation or authentication, sorry, that's replacing this key as part of the TLS. And that's where my question arises, like, it's not really augmenting authentication with attestation, having two, or let's say, as it's proposed, like multi-factor authentication or things like that. It's really replacing one mechanism, that is authentication, with the one which is attestation. And this is something that we are discussing on how to put it at a protocol level such that it can provide both. And I will pause here for a moment to see if there are any thoughts on this specific thing before I proceed to the next thing for discussion. Okay, it appears there are no thoughts. Uh, right, so the next point I have is a completely separate topic, not from, I mean, orthogonal topic to this, which is still related to attested TLS, but it's more about the nonces rather than the keys. And here I have a hierarchy of how to visualize it at a very high level. Attested TLS protocols could have no attestation nonce at all. And just a note or a side note that these attestation nonce, when I'm saying that, that's completely orthogonal to the TLS nonce. In TLS, the two participants, the client and the server, both have their own nonces, client nonce and the server nonce as part of client hello and server hello respectively. So this is meant to be a attestation nonce which is orthogonal to both of these. And so when I say no attestation nonce, it means it still has these TLS nonces, but not a specific nonce related to attestation. And single role generated attestation nonce, meaning that a verifier, relying party, or a tester can generate a nonce on their own. And multi-role, where in the same protocol, multiple of these roles, for instance, the verifier and both verifier and relying party generate a nonce, or some other combinations. And here, from a security perspective, there was also a discussion on rats, but for EAT, one of the things was attester-generated attestation nonce. In the specification, it said something like, it is typically outside of the attester, but it never said that it's always out. It should always be outside the attester. And to me, it doesn't make sense to have it as, of course, I have put it in hierarchy just for completeness, but I still don't get any sense why a tester should generate an attestation nonce. It's an untrusted party. When we don't trust its identity, why should we trust its attestation nonce? It can change all the time, and it can claim whatever it wants to be. So this, in my view, adds no security. Even if, let's say, we have that, that's basically adding no security at all to the tested TLS solution, or in general to the confidential computing solution, which is using the attested TLS as part of it. So I'll pause again to see if there are any thoughts around this.
So Osama, just you talked
Yeah,
about attester generated nonce. Could it be
yeah.
that what context is it? Is it actually if it is attester verifying the relying party, or the it is acting as a kind of a in a role where it is verifying the another party? Then it could be that use case where attester generated the nonce in
Oh,
mutual.
that's yeah, yeah, yeah. Mutual. You mean something like mutual attestation?
Yes.
Okay, very good point, Yogesh. So here I am only assuming that the attester, so one-way attestation.
Okay,
Sorry, it's not clear, and I also didn't explicitly say it. It should be explicitly stated. So I'm only talking about the one-way attestation, where only the attester is the one which is being analyzed or under test,
okay,
and not the other way around. That is, the relying party or verifier are not being attested. And my claim is also, another side note for this is that this doesn't apply to the composite attesters like in the ARM CCA. So um, there it's used there that nonce field is used to link the two platform attestation and also the, how is it called, the workload attestation or something like that. I forgot the names. But anyway, so my idea is that a single layered attester, in that case, I would argue this, and as Yogesh pointed out, one-way attested, in a one-way attestation with single layered attester, this would not add any security at all. That's precisely my claim. Okay. Any other thoughts or comments on this before I proceed to the next? Okay, so let's proceed to the next one, which is this interoperable RETLS, one of the adopted SIG projects. Um, and it's now showing in the form that we have the RATS architecture background check model, namely the server presents its evidence to the client, or in other words, in terms of the remote attestation rules, the tester provides its evidence to the relying party, and that is done here as part of the certificate message of the TLS. And then the relying party will forward this certificate or the evidence, certificate containing that evidence to the verifier, and verifier will verify, send over the attestation results, and then it will verify the attestation results at this point, and then make a trustworthiness decision whether to trust this attester or not. And as we have already discussed, so this is transforming that two-party model, which we previously had, verifier combined with the relying party, to separate roles in this case, and a specific case in which the attester acts as the TLS server and relying party acts as the TLS client. And here there was a bit of ambiguity about this channel, which is how to kind of model this part of that, namely the connection between the relying party and the verifier. I have currently considered it as a one-way authenticated channel, meaning that the relying party has the authentic public key, authentic long-term public key of the verifier. And under that assumption, I'm doing the analysis. And one specific point that I want to highlight here, and kind of related to this is the no attestation nonce solution, where there is no attestation nonce. There is a nonce from the client, that is the TLS client nonce, that is the nonce from the server, that's the TLS server nonce, but there is no specific attestation nonce from any of these parties. So this relates to that specific solution, or lies in that category of the solutions. And related to this, I have the point that I want to come to the for discussion is, it should be precisely specified what exactly is measured. For instance, whether the kernel is measured or not, and whether the OS or the app is also measured or not. And depending on these things, there can be a man in the middle attack, which could be something like this, that it sends over an R data, the user data, and if the OS was not measured, for instance, the OS would send over this request for evidence generation at a genuine attester. It will generate that evidence, and send over this back to this man in the middle, and then it will, because it has this key now, it will generate that certificate and provide its proof of possession of that key. So this is the key that I'm talking about, priv ek. And then based on this, it will generate that certificate, provide the proof of possession, send over to the relying party, exactly following all of this procedure, whatever is mentioned here. The relying party forwards this certificate exactly as before, where it did this part, and the verifier will then verify that following the procedure, generate attestation results. The verifier will verify that, oops, this one, this verification, and based on that, after verification, it will open the secure channel to man in the middle rather than the attester itself. And that's where I think it's really important. One should really specify what exactly is measured in a specific solution, whether it's let's say a cloud or a private thing. So in both scenarios, it's really important to say what exactly is measured rather than just saying that it's attested, which doesn't make any sense rather than that. So we should really specify exactly what is measured and what protocol is being employed for that. Okay, so I will pause here for a moment to see if there are any thoughts. Okay, seems all good. Then I proceed to the last point, which is identity of the VM-based TEE. So we have the general properties, and one of them is authentication. Going back to the very first slide where I talked about attestation and authentication. Ultimately, what we want to do from this kind of protocols is to identify this attester. And I want to get some intuition of how people here think about this identity of the VM-based TEE. Specifically, I am willing to have the kind of discussion about whether the load time measurement and the runtime measurement constitute an identity of this kind of TEE, or is there something in addition to that? And if yes, what exactly that is? On what basis would a verifier say that yes, this is the attester that or this is a genuine attester, or a relying party, let's say, would identify that. So how do we currently think about this identity?
So by identity, do you mean the identity of the specific instance of the VM, or
Right.
okay? So
But go ahead. But what was the second thing? Sorry, I interrupted. So what was the second thing?
that could be like a generic type. So for I'm coming from a cloud computing background. So let me
Mhm.
by saying, okay, this is an instance of a particular VM shape. That's one thing you can identify. The other thing is identify some exact details about the owner of the instance, just so that you can, because the measurements from a VM shape would be the same for all VMs in the cloud, right? So you can't distinguish it from one VM to another. So it is not, it is some kind of an identity, but it is not a unique identity of a VM instance. Whereas if you identify the owner of that VM instance, that's a bit more unique. So I'm trying to figure out what you meant by the identity.
Okay. So I think I would say both, because I eventually, so currently I was just trying to understand how to think about this, because I heard opposing opinions. Some people were saying, hey, yes, that's the measurements, meaning the load time and the runtime measurements, are a unique identifier of a VM. but I also don't think so it's the case. And another issue or conflict in my mind is we talk about, specifically in attested TLS, we talk about the freshness property. That's actually my next point also. So if we say we need we need freshness, and at the same time we say that the measurement load time plus runtime measurement is a identifier, and if or the identity, if that identity is changing, how can I claim both things at the same time? This is kind of the conflict that I have in my mind. I'm not sure if I clarified that, but does that make sense? So I'm trying to say that we are trying to design a protocol which would have freshness, but at the same time, the folks around are saying the load time and runtime measurement is a unique identity with which I identify that attester. If that's the unique identity, and going back to definition of authentication, which is a long-term credential, and thinking about workloads which have long lifetime, for instance, I have a conflict in mind to how to avoid this contradiction in the statements itself, that an identity is stable, which is the runtime measurement. It's not changing, but at the same time, I need freshness. So that's the kind of conflict in my mind. Does that make sense?
Yeah, I think I'm following you.
Okay, great.
So there is like yeah. So how do you ensure that the measurement that we are is not like a replay of some measurement, and we want to ensure the freshness of whatever we are measuring. Also, you want to uniquely identify the VM instance. So at least like what we are planning to do at in our cloud is we
Mhm.
have a instance ID provider system, which itself provides uh, which is an attester. It's like Sev S&P, etc. It is an attester. So it will generate a signed claim. Say, okay, this is the ID of this instance, and then that it will be signed by the service. It will also become part of the evidence pool. So once the verifier verifies all the evidence, then
Mhm.
you get a result with most of the results similar to all the VM shapes, except for the instance ID part that's unique to that particular instance. And that's how like we plan to uh, identify instance. So for that requires additional system that's specifically designed to provide instance identity. That's one solution, but I'm also curious to see if people have better ideas on how to do it.
Okay, thank you. That was very insightful. I didn't know about this solution. Let me try to quickly summarize what I understood. So what you are saying is, in addition to this attester that I actually want to identify, there is, let's say, a copy of this or another additional role, which you probably called instance provider. So there is, let's say, additional VM, and that's also running in a confidential computing environment. And it kinds of assigns a unique identity to this specific VM. And now the verifier, what it will do is based, and that VM will also provide something to the verifier in order to verify that. That is the kind of a certificate or something like that, probably. And a relying party explicitly needs to trust this additional entity because I think it's kind of replicating the problem to think like what I called how do I verify the verifier. So I would kind of ask here how would a relying party or a verifier actually verify this new entity that you have added? How do I build trust with that? Isn't it, don't you think that it's shifting the problem of verifying or appraising the attester to that new instance provider VM? Did I get it right or did I miss something?
No, I think like I understand what you're trying to say. So what
Mhm.
is like the root of trust for the evidence that the instance provider generates, right?
Right, right.
I
Mhm.
so for example, for SEV SNP, the root of trust is AMD. So you can trace the evidence integrity back to the AMD root key.
But
But
I, but
this
but but that's not something that I'm interested in. I'm interested in a different question. So
correct,
is
and
that, so did that instance VM, the new role that you or entity or whatever, let's call it. So that instance provider, of course, it runs in the VM, but do I as a relying party, or do you have open source code for that for me, let's say to analyze or to establish trust that it issued identity to this attester, let's call it attester, genuine attester, and there is somewhere here another malicious attester. How do I know that it uh, issued to this correct identity to this one and not to this malicious one? This is the kind of problem that I am thinking about. It has nothing to do with SNP, so I think it has to do with what is the code that is running on the that instance provider VM.
yeah,
Does
I
that
that makes sense. I was just giving SEV SNP as an example for root of trust.
Mhm.
What I was going to say is the instance metadata service, at least at Oracle, is a hardware which is a bump in the wire. So it is like a FPGA that's loaded with some code, and that can sign the instance metadata with uh, Oracle's key. So when an instance requests the instance metadata, the bump in the wire hardware will intercept that request and return the token with the metadata as well as the signature. Uh, so someone can trace that back to Oracle key. So Oracle would sign it, saying, "Hey,
Okay.
I'm the provider of the VM instance, and I'm telling you that this instance has this identity."
Fair point. I think I'm fully following, but my only concern would be I, as a relying party, wanted to remove cloud provider from the TCB, and it's still the cloud provider which is signing the evidence for this. So it's still kind of confusing in my mind that this, I mean, we wanted to solve the problem to do this without having the cloud provider in the TCP. And I guess the solution that you are mentioning by the new rule, you have the instance provider VM, although it's running in the SAV SNP, it's being signed by Oracle, and I still need to trust Oracle.
That is correct. And that's why I was wondering if there is a better solution to this problem.
Okay. Mhm.
The only reason in this case is that the instances are um, provided by the cloud provider, right? So there is no one else who would know what who this instance is and how it is represented
Mhm.
in the cloud, because each cloud has their own way of representing an instance. So this is what we currently have, but I'm looking forward also to discussing better solutions to this problem. But I understand that We want to remove
Okay.
cloud provider from the TCP.
Okay, thank you. That was insightful. And if maybe in the notes or in the chat you can put it, if there is any link, that would be very interesting. I didn't know about this solution. And one quick question, if I may ask you, Jag. In the beginning, you mentioned two things, instance of VM or the owner. So I think the solution that you are mentioning is providing identity in the form of the instance of the VM. It has nothing to do with the owner. Is it correct?
So the instance metadata actually has the owner's public key in it. So when they create a VM, and they specify, hey, this is my public key. So that information will be there too. So you can use the public key in that instance metadata to uniquely identify the owner of the VM.
But the owner of that VM will still be Oracle, the new VM, the instance provider VM. That would be, the owner would be Oracle itself, right?
The instance provider is actually not a VM. It's like a FPGA card in the
Okay.
But the instance data will be the owner of the VM. The instance data will have information about the owner of the VM.
Okay, now I'm a bit lost. So previously I thought there is a VM which is kind of issuing the instance, and how you say there is FPGA. So is it the VM and then there is a FPGA connected to it? Is it something like that? Or
There is. I'm sorry, I confused you. So there's only one VM. That's the TEE. At least,
right, so this one, attester.
yeah, the tester.
Yeah.
And then that TEE will send a HTTP request to a specific IP within the
Mhm.
cloud, and then that bump in the wire card will intercept that IP request, and it will serve the instance metadata signed by Oracle.
Okay. Okay, so there is no separate VM, so that's just intercepting that HTTP request and then signing that.
Yeah.
Right, thanks. So any other thoughts from other people or any
Yeah.
follow-up discussion on this?
So Usama, I think you mentioned that one thing is not clear to you is that the cloud provider is signing the evidence, right? Which use
Mm,
case were you referring to? Because in the CC use case, the expectation is that the underlying hardware platform and the kind of associated firmware that runs on that is supposed to maintain the evidence and its signature, right? Which is not the control of
sure.
the which is not in the control of the cloud provider. So I was a little confused when you said thing you don't understand is when the cloud provider signs the evidence. So which use case were you referring to
Okay.
specifically?
Right. So I was only referring to the solution that JAG was proposing or is implemented
Okay.
by or proposed by Oracle, so to say.
Mhm.
Uh, in that case, why I was saying was that it's still a built-in trust required in that process for the cloud service provider. I, as the relying party, will still need to trust that uh, Oracle Cloud in order to sign that and to issue that identity correctly. It
Mhm.
could be, just as an example, it could be the case that, for instance, instead of assigning, let's say, identity 123 to this attester, it assigned to its own maliciously created VM. And then they tell
Yeah,
me that, hey, this is the identity. So that was the kind of conflict in my mind.
correct. No, I think yeah, the security boundaries and the trust model for that use case will be different than the CC use case, where indeed the cloud provider should not be trusted in the CC use case.
Right.
Yeah. Yeah.
Good. So, any other thoughts? Okay, if not, then let's proceed. Um, yeah, so thank you, Jag and Yogesh. The next point in my mind is this freshness of the evidence. We had very long discussions in the SIG also. Also in the RATS, we had some discussion about this. And the particular kind of a subset of the case that I want to discuss is a VM-based TEE, and within the subset of a long-lived workload. And here I want to, or the kind of question in my mind is, first thing in my mind is, let's say, independent of whatever use case I have, I think the protocols should be designed for as general purpose use as possible. It should not be limited to, let's say, I have a small use case where SGX measurement is never changing throughout the lifetime of the whole, throughout its whole lifetime. I believe whenever like many years ago when TLS was invented, there would definitely have been some use cases where freshness was not required at all. There might be some small use cases, some big use cases, or whatever the case be. Protocol should be designed for a generic purpose use case. And there, I believe, independent of whether there is consensus on having that or not, I think the protocol, if we extend the protocol, it should be in a way that it keeps it as generic as possible. If someone has a use case, for instance, where freshness is not required, it's fine. So we don't do any harm for that. We provide an additional thing which people can use. And if they don't need it, of course, it doesn't do any security harm. On the other hand, if there are some things which are changing at the runtime and freshness is not provided, I believe that is harmful in a sense that it really damages the security, that it's a man in the middle can then give an older status, and it doesn't even have to be man in the middle. It's even possible without, independent of this man in the middle, that this instance had a different status in the beginning. It keeps replaying that evidence, and the status has changed. It has been compromised, but the verifier as well as the relying party will still believe that it's not, it's still the same if it keeps replaying the older, the older evidence. And there I want to kind of come back to this point and try to understand what is the kind of criticism against this point, specifically for long-lived workloads, where I believe freshness is important to see, like what is happening at the runtime. Different events need to be logged and be given status to to the relying party or to the verifier. And I want to understand better why people, or why some people think that freshness should not be provided by attested TLS protocols. Okay, I don't hear anybody, so let's proceed. Final point in my mind was that I talked about authentication and attestation, differentiating them in the beginning, referring back to the discussions at RETS. And the problem still we have is this, the TLS protocol in itself can provide proof of possession of only one key. And going even back to this one, I can either use this long-term key or this key, but not both. Meaning, at a very high level, I can either provide attestation or authentication, but not both. And that's what we actually want to have. We want to augment authentication with attestation rather than replacing one by the other. And I was wondering if someone has any thoughts or someone has been working on topics around this, there has been a while, I think we talked about it way back 2 months or even more ago, before governance stuff was in the SIG. So I was wondering if someone has any thoughts around this idea to augment authentication, augment attestation with authentication in the TLS protocol specifically. Okay, probably no ideas. It's fine. So I just wanted to put out these things to have some discussion. I think I'm finished. So I have one quick announcement to make. So I think many of you might already know that we have the FOSDEM attestations dev room, and alongside we are organizing a workshop, and Jag is presenting there as well. So hopefully I will put a link to that in the chat. We have arranged for the workshop online attendance also, and it's going to start at 1. So hopefully if you want to attend online, you are very welcome to attend as well. FOSDEM itself is you can attend also online. Cool, then thanks a lot. Unless someone has something else to say, I will copy the links in the meantime. Thank you, Jag, for the link.
Yeah, I've put all of these links. I'm getting them into the document now, but if there's anything else that would further this discussion, absolutely do add it onto the attestation meeting minutes. But thank you all.
Thank you, Saul. Thank you very much. Thank you, everybody. Bye.
Cheers, bye.